Analysis of variance is a powerful statistical tool for test of significance. The test of significance based on the t distribution. So the difference of two means. More than two sample means we use Anova, analysis of variance. The analysis of variance introduced by R.A. Fishers in the year 1920 based on the agronomical data. Definition of Anova. According to R.A. Fishers, analysis of variance is the separation of variance to one group to causes from the variance of other group. Assumptions of Anova. The first assumption, observations are independent. Second one, samples are drawn from normal population. Third one, various treatment and environmental effects are additive in nature. Anova classified into two ways. One is a one-way classification, another one is a two-way classification. One-way classification means one-side calculation. Either it is a row or column. Let us suppose capital N observations. The observations are, we have to denote it by the Yij. For all I ranges 1, 2, 3, 4 up to K, J ranges 1, 2, 3, 4 up to Ni. So the Y are grouped into K classes. The class sizes are N1, N2 up to Nk. So that means capital N equals to I ranges 1 to K Ni. Observations are classified into K classes of sizes. We have to show the table. The total variance in the observation Yij can be split into the following two components. The component number 1, the variation between the classes, or the variation due to different basis of the classification. So it is called as a treatment. Second one, the variation within the class, that is the inherent variance of the random variable within the observation of class, is known as a error. Now we want to check the test of equality of population means, that is homogeneity of different classes, that is H0 mu1 equals to mu2 equals to dash dash up to mu k. That means population means are equal. The statistical analysis of one-way classification. So write some notation. Y bar I dot is the mean of the ith class. So that is y bar I dot equals to 1 by ni, j ranges 1 to ni yij, and one more notation, y bar double dot. So E is called overall mean. The overall mean y bar double dot equals to 1 by capital N double summation I ranges 1 to k, j ranges 1 to ni yij. One way classification model equation, yij equals to mu plus alpha I plus eij for all I ranges 1, 2, 3, 4 up to k, j ranges 1, 2, 3, 4 up to ni, where mu is called population mean, alpha is called the effect due to the ith treatment. So eij is called IID, identical independent distribution, or error effective. Now we are estimate the parameters mu and alpha of the model equation. So the parameter we have to estimate by using the principles of least square, minimizing error sum of square. So here we have write the error value. The error Eij equals to Yij minus mu minus alpha I. So here we have find the mu and alpha value by using the principles of least square, minimizing error sum of square. The error value E equals to double summation I ranges 1 to k, j ranges 1 to ni, yij minus mu minus alpha I whole square. Partial differentiation with respect to parameter mu and equaling to 0. That is dou E by dou mu equals to 0. So differentiation for the right hand side. So the power differentiation first, 2 into double summation yij minus mu minus alpha I power 2 minus 1. So for the term differentiation, yij value we get the 0 minus mu value 1 minus alpha I we get the 0. After simplification, minus 2 double summation yij minus mu minus alpha I equals to 0. After that, the parameter mu convert into y bar double dot. Again partial differentiation with respect to parameter alpha I and equaling to 0. So here also we have to the power differentiation. So 2 into summation j ranges 1 to ni yij minus mu minus alpha I power 2 minus 1. So actually we have here two summation, but here we can write down by the single summation only. So we differentiation with respect to alpha and I. So the I value, the summation I value we can convert into 1. So again partial differentiation with respect to alpha I and equaling to 0. So here we have to power value. So here also the same thing we can done by the previous differentiation. So 2 into summation j ranges 1 to ni yij minus mu minus alpha I power 2 minus 1. So in term differentiation, yij we can convert into 0 minus mu we can convert into 0 minus alpha I we can convert into 1. So finally we get the minus 2 summation j ranges 1 to ni yij minus mu minus alpha equals to 0. The minus value equaling to 0, we get the value summation j ranges 1 to ni yij minus mu minus alpha equals to 0. So now we apply the individual summation value. So summation j ranges 1 to ni yij equals to summation j ranges 1 to ni mu plus summation j ranges 1 to ni alpha I. So in our yij we have j value, so we can't change that value, but mu and alpha I, it's a constant value. The constant into summation we get the size into constant. So that means n into mu plus n into alpha equals to summation j ranges 1 to ni yij. So in that we write the alpha I. The alpha equals to 1 by n summation j ranges 1 to ni yij minus n I mu. Finally we got alpha equals to y bar I dot minus y bar double dot. So after we getting the mu and alpha I value, substitute into our given model equation. The model mu and alpha value substituting into given model equation. So the mu value y bar double dot, alpha I value y bar I dot minus y bar double dot. So the values are substituting into given model equation. The model equation yij equals to mu plus alpha I plus eij. So in that mu we replace the value, we estimated the value y bar double dot and alpha I value, so y bar I dot minus y bar double dot and eij value. Substitute the eij value, yij minus y bar double dot minus alpha I value y bar I dot minus y bar double dot. So some simplification, we cancel the term and we get that yij minus y bar I dot. So finally we write that value yij minus y bar double dot equals to y bar I dot minus y bar double dot plus yij minus y bar I dot. Next, summing over I ranges 1 to k and j ranges 1 to ni, and also squaring on both sides. We get that double summation I ranges 1 to k, j ranges 1 to ni, yij minus y bar double dot whole square equals to double summation I ranges 1 to k, j ranges 1 to ni, y bar I dot minus y bar double dot plus yij minus y bar I dot whole square. So here we get the a plus b whole square form. So simply we write a square plus b square plus 2ab. So now apply a square plus b square plus 2ab form. So the double summation I ranges 1 to k, j ranges 1 to ni, y bar I dot minus y bar double dot whole square plus double summation I ranges 1 to k, j ranges 1 to ni, yij minus y bar I dot whole square, and cross product terms are vanished. So observations are independent, then the cross product terms are vanished because of the covariance term. X and y are independent random variables, then the covariance of x comma y equals to 0. So that means the product terms are zeros by using that concept. So here we take the cross product terms as a 0. So we get that value. So double summation yij minus y bar double dot whole square equals to double summation y bar I dot minus y bar double dot whole square plus double summation yij minus y bar I dot whole square. So the value simply we write that TSS equals to SST plus SSE. TSS means total sum of square and SST means sum of square due to the treatment, and SSE equals to sum of square due to the error. After finding sum of square, now we write the degrees of freedom. So the degrees of freedom for total sum of square TSS. So the total sum of square containing capital N observations. So we get n minus 1 degrees of freedom. 1 degrees of freedom being lost because of it is a linear constraint. Next degrees of freedom is sum of square due to the treatment. So the population we deviate into k classes. So we get k treatments. So in that we have k minus 1 degrees of freedom for the sum of square due to the treatment. So 1 degrees of freedom loss because of it is a linear constraint. So the degrees of freedom of error. So we know that TSS equals to SST plus SSE. So the degrees of freedom for TSS, we get that n minus 1 is equals to treatment k minus 1 plus error. So error equals to capital N minus 1 minus k plus 1. So plus 1 minus 1 cancel, we get that capital N minus k. So there is a degrees of freedom for the error. So after degrees of freedom, we discuss the mean sum of square. So what is the definition of mean sum of square? The sum of square divided by the its degrees of freedom is called mean sum of square. So the mean sum of square first we can find out by the treatment. That means MSST, mean sum of square due to the treatment. So the mean sum of square due to the treatment is equals to sum of square due to the treatment by k minus 1. Same thing we can find out by the error. MSS equals to sum of square due to the error SSE by capital N minus k. we get the mean sum of square due to the error. So next we write the Anova table. So in our Anova table we have to follow some columns. Column number 1, source of variance. Column number 2, sum of squares. Column number 3, degrees of freedom. Column number 4, mean sum of square, and ratio or F test. In one-way classification, the Anova table has sources are treatment, error and total. Sum of squares, capital S square small t, capital S square capital E, capital S square capital T. Degrees of freedom for treatment, k minus 1. Degrees of freedom for error, capital N minus k. So the total of treatment plus error equals to n minus 1. So after that, variance. The variance means mean sum of square. So it we get the sum of square divided by the degrees of freedom. So and after that we write the ratio F test. F is equals to treatment by the variance mean sum of square of treatment by mean sum of square due to the error, or mean sum of square due to the error by mean sum of square due to the treatment. So the degrees of freedom are k minus 1 comma n minus k, or n minus k comma k minus 1. After getting f, write the conclusion. So the calculated value of f is less than or equals to the tabulated value of f with k minus 1 comma n minus k degrees of freedom at alpha percentage level of significance. Then accept H0, otherwise reject H0. Thank you. Please subscribe my channel. My channel name is Baswaraju Buyya.